Okay, so our group is going to present the global warming and water. First of all, I'd like to introduce the topic explaining what is climate change. Well, there is clear evidence for substantial variations in the Earth's climate globally and regionally, uh, and they range from many years to many millennia in duration. Due probably to human activities contribution, has played an important role on that. So if you see that graphic over there, it's showing the internal and external factors influencing climate system. And this is the hydrological cycle. So the human influences a lot, especially in those gases released from cars and factories. And these gases are going to cause changes in the atmosphere, uh, changing the composition and also the air circulation and releasing particles, and especially carbon dioxide in the atmosphere. It's going to change also the hydrological cycle because it's going to interfere in the clouds, causing acid rain. That by this way is going to interfere in the vegetation, also in rivers and lakes, and affecting surface and subsurface water. The second part is the climate system components. Among these variations in the atmosphere, we can see that they are both influenced by and also interacts with other parts of climate system, uh, especially in the internal and external components. So, skipping to this second graphic, we can see the diminution of oxygen in Earth changing climate in the last 10 million years. So if you see the vertical axis, it is showing oxygen isotopes from ocean cores. That is a good way of measuring oxygen in prehistorical climates, and today it has diminished. On the other hand, in the green part of the graphic, you can see that carbon dioxide rates has increased a lot, especially in the last 10,000 years, probably due to human activities in agriculture or raising animals, and etc.
Scientists use a variety of scenarios to project how much warmer it might get by 2100. The best case scenario predicts that average global temperatures would rise by 2 degrees Fahrenheit, and the worst case scenario projects that they would rise by 11.5 degrees. This can be hard for most people to understand, so a similar way of thinking of it is if the human body got a fever. If a human body's temperature rose by 2 degrees Fahrenheit, that person would have a fever, indicating that something is wrong. If it rose by 11.5 degrees, the human would most likely be dead, and in the case of Earth, catastrophic consequences would most likely occur. This is a graphic of the greenhouse effect, which allows radiation from the sun to pass through the atmosphere. Some of this radiation is absorbed by the surface of the Earth, and some of it is reflected back into space. When there are higher concentrations of greenhouse gases in the atmosphere, more of the radiation is kept within the atmosphere of the Earth, causing temperatures to rise. The rise in temperature will also affect precipitation patterns globally. Areas that are already dry will continue to get drier, and areas that are wet will get wetter. The effects of climate change on water are varied and in their severity and location. Sea levels around the world will increase, providing more salt water and coastal areas and less fresh water for drinking and human use. Changes to precipitation amounts, patterns, and intensity will occur. There will be greater rainfall, greater frequency of rainfall, and greater intensity in rainfall. This includes tropical storms such as hurricanes, which will become more intense and cause greater damage as they grow larger. There will also be decreases in ice, snow, and permafrost, which are major sources of drinking water for many mountainous countries. As sea temperatures rise and carbon dioxide levels rise, ocean acidification occurs. When there is more carbon dioxide absorbed into the ocean, the pH level in the ocean drops. This prevents many mollusks and other aquatic creatures with calcium-based shells from fully developing those shells. This includes corals as well, and having more difficulties for these animals to develop their shells will affect the whole aquatic food web.
As you can see, global climate change with its effects is one of the most important issues of the 21st century. Russia, like other countries, is affected by global climate change. According to the Russian Federal Service for Hydrometeorology and Environmental Monitoring, Roshydromet, in 2007, annual average temperature exceeded the average value for the previous 121 years by 2.1 degrees Celsius. From my perspective, continuation of this trend may lead to undesirable and even dangerous effects on natural and economic systems as well as on human health. Under the Arctic region, I understand everything that lies to the north of the North Pole. How does global climate change affect the Russian Arctic? First and foremost, the average air temperature in the Arctic goes up. Moreover, average air temperature growth in the Arctic is more intense than the one in other parts of Russia. Over past 40 years, the average air temperature growth in the Arctic amounted to 1.5 degrees Celsius. One of the peculiarities of this growth is that it happens all over the Arctic region. The reasons for the air temperature increase in the Russian Arctic are permafrost thawing, sea ice melting. As a consequence of these, land warms up and soil heats. As you can see from the slide, a reduction of the ice cap area is one of the serious challenges to the Russian Arctic. If the winter maximum that is calculated in mid-March in 1979 was about 15 million square kilometers, in 2011 this figure was less than 14 million square kilometers. The same downward trend happened with the summer minimum during these 40 years. If in 1979 the summer minimum amounted to about 5.5 million square kilometers, in 2011 it was about 3.5 million square kilometers. If we look closer to the summer minimum, we can see that this parameter diminished over past 40 years by 50%. But what can we see from the slide? We see that the global warming is not a strictly downward trend. Inside this, throughout this period, the ice cap area fluctuated. But still, if we compare the beginning of the period and the end of the period, we can see that the ice cap area diminished. A reduction of the ice cap area leads to the changes in the marine ecosystems in the Arctic. These changes are local now, but if air temperature continues to grow in future, changes might become omnipresent in the Arctic region. Now we can talk about three types of marine ecosystem changes in the Russian Arctic. The first change occurred in the eastern Siberian Sea, and it led to the changes of the ice regime, and as a consequence of the ice regime change, white bears could not adapt anymore to the global warming changes immediately. Also, in this region, we can observe the changes of the walrus rookeries. The main problem is that either white bears or walruses cannot adapt to global warming challenges. They cannot live without ice, but the permafrost thaws, and they cannot find a suitable habitat for themselves. Similar changes were observed in the Barents Sea, that is the second circle on my slide, and here we observe the changes of the Atlantic walrus rookeries. But the reason for this is extensive oil and gas extraction in the Barents Sea. And finally, the third change in the marine ecosystem happened in the White Sea. Here we cannot say whether seals will continue to live in this region or not. Their habitats were strictly affected because of the rise of the sea level and because of the rise of the temperatures. They cannot live anymore in these habitats, and because of a great number of islands, they cannot go to open sea, that is to the Arctic Ocean, and look for new habitats. Now I will show you the pictures of these animals. This is a white bear or a polar bear. This is a walrus, and this is a seal. At the beginning of my presentation, I said that global climate change leads to soil heating, permafrost thawing, and sea ice melting. As a result of these tendencies, the terrestrial ecosystem also changes. The terrestrial ecosystem that lies to the north of the North Pole is called tundra. Tundra gets green earlier, and period of vegetation in the 2000s starts 2 weeks earlier than it used to in the 1990s. Finally, I would like to talk about coastal erosion. As a result of sea ice melting, a number of storms increases. On the slide, you can see the pictures of the Novosibirsk Islands. These are one of the biggest islands that belong to Russia and that are located in the Arctic Ocean. They are affected by the coastal erosion, and apart from coastal erosion, there is an increased number of winds, storms, but luckily enough, we still have not had hurricanes so far in this region. I would like to conclude what I have just said. The global warming led to significant changes in the Russian Arctic, and these changes can be divided into several categories. First, average annual temperature increased. Second, we can observe permafrost thaw. Third, we can also observe the decrease of the ice cap area. Fourth, marine and terrestrial ecosystems change, and global warming may lead to drastic changes in these ecosystems in future. And finally, coastal erosion happens in the Arctic region.
Now I'm going to tell you about the case of South Korea. First of all, I want to talk about evidences of climate changes in South Korea. Concentration of carbon dioxide has increased every year. In 1997, Korea's CO2 increasing rate recorded the highest among 49 countries, and also temperature has increased constantly since starting record. Now I'm gonna talk about impacts. One of significant impact is increasing of ocean temperature. Sea temperature in South Korea has increased 1.3 degrees Celsius. It equals 34.4 degrees Fahrenheit, while global average is only 0.5 degrees Celsius. To make matter worse, the annual temperature variation is very strong. People might think this is small changes, but fish experience 20-degree variation even they are actually only 1 degree change. They cannot adapt this situation, so the amount of fishes and diversity is now decreasing. In the East Sea, there is a boundary where the cold current and warm current meet. In there, we can find various species. But as ocean temperature is increasing, the boundary is going northward. It affects fisheries and economics. In 2011, Korea experienced the heaviest rain since we started recording. Rain fell 2 inches an hour, and over the past 24 hours, 400 millimeters, equals 16 inches of rain has been dumped on the capital Seoul, causing flash floods, landslides, and bridge closures. Officials said damage to capital Seoul and surrounding areas ran into hundreds of millions of dollars. Emergency service put the death toll at 41, with 12 people missing. 4,500 people had been forced out of their homes, and many houses were without power. One citizen said subway stations in Seoul were turned into swimming pools. This kind of situation are happening every summer. 3 days ago, water bombs happened again. One of the important subway stations were under knee-deep water. Because near the many significant business centers located, it is a very serious problem in my nation. In 2012, the worst drought in 104 years happened. The capital had received only 6.4% of the rainfall compared to the same period in 2011. During 48 days, we got only 10.6 millimeters rainfall. It is causing damage to our agriculture and livestock industry, resulting in inflation in some farm products. The drought also has led to death of highly endangered species in reservoir in the southern city of Nonsan in South Korea. Hundreds of cockscomb pearl mussels have perished since June 14th, when the reservoir's water level drastically dropped.
It's changing the picture.
Yeah, this is the heaviest rainfall picture. Now I'm gonna tell you about responses. To reduce carbon dioxide emission, government makes lots of regulation and laws, and also they give company financial support. The thing I want to introduce to you is low carbon green campus. It started by KAGCI, founded in 2008, and in 2010 there are 39 member universities and 40 member campuses. Their tasks are, first, doing research to find out what should we do or studying. Second is developing university programs. It separates two methods. One is how to reduce the usage of energy or greenhouse gas emission. The other is how to train green leaders. Last, improving environment of campuses. My university has invested lots of money into insulation, making ecology parks, and so on. I'm a little sad because I cannot take classes feeling the cold. I think it's important because we are university students, and I hope every university in the world participates in this campaign. And to prevent damage caused by changing weather system, we are improving weather prediction. Although we import numerical weather prediction, we try to make our own numerical weather prediction, because the other nation's spatial scale is too big to use. And also we educate people for understanding of climate changes, adaptation, and mitigation. We are developing various contents, and although recycling policy started 10 years ago, thanks to advertisement and education, now the percentage of recycling records 86%, and the greenhouse gas emission generated by waste is now decreasing.
Okay, so
No, this is- So there are many ways in which we can respond to climate change. The first is reducing use of fossil fuels by reducing how much energy and fuel we use in our daily lives. The second is reducing energy demand and consumption. The third is international agreements such as the Kyoto Protocol, in which multiple countries agree to limitations on their greenhouse gas emissions. And the fourth is to adapt to the changes brought about by climate change, such as sea level rise.
okay, maybe for the first measure, an interesting thing would be substituting the fuels, the fossil fuels, by biofuels in automobiles and generators. For the second measure, let me come back here. For the second measure, especially throughout recycling residues such as paper, plastic, and aluminum. And Brazil also has good programs on it. For the third one, well, USA refused to sign Kyoto Protocol, but it's very important for reducing carbon dioxide emissions. And in the last one, adapt to changes. This is a very important measure in order to avoid the extinct threatened animals such as the wolf, American wolf, and also Brazilian jaguar, African elephant, Siberian tiger, Asian panda, Australian koala, and also animals that you can see in the oceans such as the Gilbert whale and also the manatee. So the question that the group wants to ask to end the presentation is, let's keep our planet healthy for the next generation. What do you think about that?
Great, thank you very much. Are there any questions from the floor? Anyone in the room have any questions for our climate and water team here?
You guys did great.
Please, Alex.
You guys did great. Really good.
Thank you.
Thanks.
Thank you. Any questions over our line? Okay, hearing none, I get the one question. Wow. Actually, I was wondering, you ended with one of your solutions is to adapt to the effects of global warming. What sorts of things should we do to adapt? I mean, it's given that we don't seem to be mitigating the impacts very well at this point, either in your specific countries or more broadly. What are the big things that we need to be doing around the world, I guess, to be able to adapt to it if we're not going to prevent it?
Well, the biggest thing I've heard about is adapting to sea level rise. I know in the Netherlands they've done a lot with building seawalls, trying to keep, when there is an increase in sea level, trying to keep it from inundating their cities. And I know after Hurricane Sandy, they talked about doing something similar in New York City to try and protect Manhattan. And they also talked about doing it in the DC region to keep a tidal surge from coming up through DC. That's the adaptation that I'm most familiar with, is just trying to accommodate rising sea levels rather than prevent it.
What about on the fresh, or anyone have anything to add? Go ahead.
Yeah, I would like to add maybe about the Russian Arctic. As you could see from my presentation, because of the global climate change, the tundra gets green earlier, and as a consequence, the biodiversity goes up. So I think that we can use this situation to our benefit. For example, we could start growing there some plants that earlier we didn't grow in this region. Also, we can introduce some animals to this region. Maybe from the southern parts of Russia, we can move some habitats to the northern part because the weather conditions allow to do this. I think we can use this global warming sometimes.
To your advantage?
Yeah, to our advantage.
Yeah, I think I've often wondered if we interviewed the people on the street in Russia and Canada and the Nordic countries, if they wouldn't say, "Oh, you mean we're going to have it warm up, 20 days earlier? That sounds pretty good. I want more global warming." Or what the perspective would be. Certainly, Russia has such a diversity of ecological areas that it's likely to see both positive and negative impacts in the the coastal versus the interior.
And
continentals.
tundra is not diverse. Well, it is diverse. It's not all the same.
Yeah.
I mean, if you look at tundra at the European part of Russia, that is to the left of the Ural Mountains, you can introduce some habitats which you cannot introduce to the right of the Ural Mountains. That is the eastern part of tundra. So we have lots of climate zones, lots of time zones, and all this affects. So if you want to introduce something, you should pick up the specific area, not the whole tundra.
Thank you. Did you want anything?
I think we should adapt our food production. Agriculture is important to all of us. In South Korea, the temperature is more higher. We cannot plant our crops we used to use. So we have to change our crops and search for other methods to growing the crops. And also we have to search for groundwater uses and resources of water. We should find that, I think.
And I think with groundwater, we've only started to figure out how to manage groundwater. Until now, it's been just in terms of how much we take out. But now we're starting to think about how we could get water into groundwater from surface water pumped down, for example, in various places. If you're desalinating and faster than you're consuming, then you could be putting that water into groundwater storage in the right locations. And of course, reused water. Once we've cleaned it, you don't want to pour it back out on the desert. You want to put it back into some place where it's not going to evaporate, and groundwater is very useful for that as well. So that's a good observation. What about the last question like this is, what about all the settlements? If you're in a relatively dry place and it suddenly becomes very dry, or if you're in a wet place and it's even more wet, are there any thoughts you have about how we might adapt to that from water perspective? Elliot?
I'd like to say that I gave an example here about the USA, but in Brazil we suffer a lot from these problems too. We have much deforestation in the Amazon jungle, especially for planting soy over there, soy grain. And it is affecting other parts of the country, especially the south part, We are suffering from floods there, and it's affecting especially people who live in irregular regions, such as mountains, the bottom of the mountain, And it's a great problem. We have to think about that.
Okay, thank you.
You're welcome.
As far as I know, one of the worldwide recognized solutions for this problem is to change river flows. But I'm not sure that this will help, because nobody knows what will happen in the future. Maybe in 3,000 years we will have not global warming but ice age again. And if we change river flows, maybe in the distant future this won't be beneficial at all. So if from my perspective, change of the river flows is not the best solution. Maybe we could change them locally, but I don't know how to deal with this problem on a global scale.
I really appreciate it, as an ending thought, this idea of not just thinking about the spatial but the temporal scales of global problem solving, and to think, in the Chinese case, that they were building very, very long canals 2,000, almost 2,500 years ago, and so we can almost look back and say, how did that affect today's situation? Certainly, it helped geopolitically with China consolidation over the subsequent millennia, which, how did that lead to where we are today? I can't quite say, but at the same time, we can see that those things, nature tends to correct itself over time. So even in the Chinese canals situation we talked about, over time they decayed and the canals didn't work as well unless they came back and restored it. So I have a feeling even with, for example, what's happened around the Aral Sea and the rivers feeding into it, that we may divert them for this century, and the next century they'll move it back if they think it, or nature will take over and find the right way to connect to something. Maybe it's not the Aral Basin, but another basin where it's low within within that part of the Asian continent. So it'll be interesting to see. Any last comments or? Okay, well, thank you very much. Good job, guys. And that concludes our global problem solving water videotapes of our presentations. Thank you all for listening and for participating.